Welcome to week 2 of the Mathematics Best Practice series. The strategy that we'll be exploring this week is the TI Inspire as a tool for learning. The TI Inspire CX handheld is a very powerful learning tool that is used mainly in grades 8 through 12 and other specialized middle school courses such as 6th grade accelerated for AP. The handheld can be used to help students to make connections between multiple representations, make complex calculations such as calculating square roots and sines of angles, make sense of real-world applications. It can also help being a different mode of instruction through the downloadable files, and most importantly, it helps students build confidence in the mathematics. As much as it is a powerful tool, it can actually do more harm than good if used incorrectly. If it's used as a sole means of instruction, it can take away the conceptual understanding. It should be used as a tool to enhance learning, not to replace learning. It can also erode the meaning in application situations, and it can limit a student's ability to reason effectively. An example of how this can do more harm than good, the use of the InSolve as a means of teaching students how to get an answer to an equation doesn't provide for conceptual understanding of equations. It doesn't help students with the understanding and use of properties of equality. It doesn't help students with the understanding and use of inverse operations. And it also does not provide for the skill of manipulating an equation, which can hinder students' abilities to isolate for a variable in both current courses, for example, putting things into SlopeIntercept form, and then in subsequent mathematics classes and even as well as in physics. Here's an example of how to utilize the handheld to help students understand and visualize a problem situation. So the problem situation in which we will talk about is a situation in which students would be decorating the gym for a pep rally. They would need to purchase white rolls of streamer paper at the cost of $3.06 per roll and blue rolls of streamer paper for a cost of $5.10 per roll. Students are told that they have to spend less than $51 on the rolls before taxes. And in this situation, students will need to give 3 possible solutions for the maximum number of blue and white rolls they could buy. And in this particular situation, the students are looking at a situation in which it's an inequality, not an equation, because it's not exactly 51, it can be anywhere less than. So in this situation, it would be important for students to write the inequality for this particular situation, and first they would need to be able to define the variables. In this case, we're going to utilize x and y. They can actually use any variables, any letters that they would want, but since the Inspire uses x's and y's, then that's what we'll utilize for now. So defining the variables, we're going to let x equal the number of rolls of white streamer paper to be purchased, and we're going to let y be the number of blue rolls that need to be purchased. So when we're writing the inequality, we want to look at x first. So if we look at the x and we see that that's the number of white rolls, we looked at those cost $3.06 per roll. So that would be 3.06x. And then since we're combining these, we would use the plus. And then for y, the number of blue rolls, that would be $5.10. So we would note that as 5.10y. In the problem, it says less than, and then our amount is the $51. Let's get more information about the situation. So let's put this inequality in a SlopeIntercept form. So we would need to make sure that students are able to manipulate for y, and by doing that, they would subtract the 3.06x from both sides of the inequality. That would leave us with a 510y, which is less than negative 3.06x plus 1. We just rearrange those. And then finally we would divide by 510, making sure that everything was divided by 510, and that leaves us with our inequality of y is less than negative 6/10x plus 10. And here our slope would be negative 6/10, and our y-intercept would be 0.10. Now this is just going to help us make sure that when we graph this that our graph is correct. Let's get a visual of the situation by graphing the inequality. First, we would graph by going to the home page and then choosing the graph function of the handheld by moving the cursor onto the symbol that looks like a U or parabola on the graph and then click. You should see the following screens. For step 2, the students would need to delete the equal sign, and when they do that, a menu of inequality symbols appear. They need to select the appropriate inequality, for in this case it would be less than, and then type the expression that is on the right side of the inequality symbol, which in our case would be negative 6/10 plus 10. And then they would press enter. Once they've done that, a dashed line will appear with a shaded region. When the hand is over the inequality line, it will show a dashed line for less than or greater than, and a solid line for less than, equal to, or greater than equal to. Because the inequality being graphed is y is less than -6/10 x plus 10, the solutions are found in the shaded region below the boundary line. Points on the boundary line are not included in the solution set because y is less than -6/10 x plus 10, not equal to. So let's look at finding some points to satisfy our situation. The visual gives us a really good way of being able to figure out which points would be able to be a part of this. Now, looking at the whole entire four-quadrant graph is probably not going to help us with our situation, because our situation we would not be able to purchase negative amounts of rolls, so it wouldn't make sense to look at other quadrants other than quadrant 1. In addition to that, we would want to look for whole numbers because you couldn't buy a half of a roll or a 0.6 of a roll. So we're looking for simply whole numbers that are within our shaded region. We'd want to make sure that we're selecting numbers that are as close to the boundary line as possible because then we want to maximize our $51. Here we can look at potentially seeing if 9,4 could be a solution, or if the coordinate 7,5, or if 6,6 could be a solution to our situation. Let's check to see if these will work. So if we substitute in 9,4 for our x and y and solve, we get for $49.94, and we can see that $49.94 is less than the $51. So we could buy 9 white rolls and 4 blue rolls. Let's see if 6,6 would be a part of our solution. We substitute in 6 for x and the other 6 for y and solve, we end up with $48.96. $48.96 is indeed less than $51. So we could buy 6 white rolls and 6 blue rolls. And this might actually be our best answer because we could have equal amounts of the colors. So let's look at the third point. The third point was 7,5. If we substitute those in for x and y, we get $46.92. And indeed, $46.92 is less than $51. We could buy 7 white rolls and 5 blue rolls. Since there seems to be a good amount of money left over there, so could we maybe see if 7 white rolls and 6 blue rolls could be a possibility? So let's look. 7,6 looks to be outside of the shaded region, and then if we substitute in 7,6 for x and y, we indeed end up with $52.22, which is not less than $51. This has been an example of how you can utilize the handheld to help students understand and visualize the problem situation. Want to learn more about the various functions of the TI Inspire CX handheld or how to use it with your students? Come join us on April 5th at the PDC in room 235 from 5 to 6 p.m. Make sure you sign up on Eduphoria. We look forward to seeing you. Stay tuned for next week's topic, using formative assessment to check for understanding.